Hello everyone. Our topic for discussion in this video is going to be equilibrium and the principle of movements. First, let's try to understand this term equilibrium. Now, if a body continues to be in its state of rest or uniform motion, even though a number of forces are acting on it, then it is said to be in equilibrium. Let me explain it a bit properly. So there are basically two types of equilibrium. One is static and the other one is dynamic. Now, if a body continues to be in its state of rest, even though a number of forces are acting on it, it is said to be in static equilibrium. Meaning, one example would be, say, we have an object lying on top of a table. It is at rest, okay? And say there were two hooks attached, okay? On the right hand side, a force of 10 Newton was being applied. On the left hand side, another force of 10 Newton was applied. Now, this is an example of static equilibrium. Why? Because the weight of the object is acting downwards. Okay. The normal reaction force is acting upwards. 10 Newton force towards the right, 10 Newton force towards the left. They cancel out each other. Okay. They cancel out each other, and so the body continues to be in its state of rest. So when a body continues to be in its state of rest, even though a number of forces are acting on it, it is said to be in static equilibrium. Now let's understand dynamic. When a body continues to be in uniform motion, okay, meaning continues to move with a constant speed, even though a number of forces are acting on it, it is said to be in dynamic equilibrium. Examples here will be the planets revolving around the sun. The gravitational force of the sun is holding the planets in orbit. They are not allowed to drift away, but the planets keep revolving at a constant speed. So that is an example of dynamic equilibrium. Another example could be electrons revolving around the nucleus. So these are cases of dynamic equilibrium. So for a body to be in equilibrium, next, okay, we have to understand conditions for equilibrium. So for a body to be in equilibrium, either static or dynamic, firstly, the net force acting on a body should be zero. So this situation, the net force here is zero. Or we can say the algebraic sum of all the forces acting on a body should be zero. If this is plus 10, this is minus 10, they cancel out each other. This is plus, this is minus, cancels out each other. So the algebraic sum of all the forces acting on a body should be zero. Then the second condition is the resultant movements should acting on a body should also be zero. Okay, or in simple language, anti-clockwise movement should be equal to the clockwise movement, and that becomes the basis for principle of movements. Okay, so next is your principle of movements. The principle of movements is basically a continuation of that second point of the resultant, movement should be zero. Principle of movement tells us that in equilibrium, the sum of the anti-clockwise movement should be equal to the sum of the clockwise movement. So supposing we have a situation where, say, there are two forces here. Say there is force F1 acting at a distance d1 from the axis of rotation. Here there is another force F2 acting at a distance d2 from the axis of rotation. This is fulcrum or the axis of rotation. Okay, you get confused with the word F, so I'll put a O here. This is the axis of rotation. Now, on the other side also, we could have multiple forces. Say there is a force F3 acting at a distance d3, and there is a force F4 acting at a distance d4. So altogether, there are four forces. Now, these two forces, F1 and F2, are creating anti-clockwise movement. Because of these forces, this rule is trying to fall downwards like this. And on the other side, F3 and F4 are creating clockwise movements. Because of the forces F3 and F4, this is how the ruler is trying to fall. So Here it's anti-clockwise, this side is clockwise. Now, according to the principle of moments, in equilibrium, means if this is balanced state, in equilibrium, the sum of the anti-clockwise moment, now let's first moment created by force 1, F1 d1, okay, plus the sum, remember that, F2 d2 is the second moment. The sum of the anti-clockwise moment will be equal to the sum of the clockwise moment, meaning F3 d3 plus F4 d4. Basically, this is the principle of moment. In equilibrium, the sum of the anti-clockwise moment is equal to the sum of the clockwise moment. And this is going to be the fundamental for your numericals. If you understand this portion very clearly, there will be absolutely no problem in solving the numericals. Any one of these terms could be missing, either F1 or F3 or D2 or D4, which you have to work out. The rest of the information will already be given in the sum. All right, let's try this numerical based on the principle of moments. The question says a uniform meter rule is pivoted at its midpoint. A weight of 25 GF is suspended from its one end. Where should a weight of 50 GF be placed so as to balance the rule? So here we have a situation where a uniform meter rule, so say this is the uniform meter rule, is balanced at its midpoint. So if supposing this is 0, this is 100 centimeter, this rule has been balanced at its midpoint, so at the 50 centimeter mark. A weight of 25 GF is suspended from its one end. So 25 GF from one end, now it's upon us to choose which end we want to suspend the weight from. Supposing I decide to put it here. So there is a weight of 25 GF which has been suspended from its one end. Where should a weight of 50 GF be placed so as to balance the rule? As we can see here, this 25 GF force is creating an anti-clockwise movement due to which this ruler is trying to fall down. Okay, so obviously we have to put the 50 GF to the other side. So 50 GF somewhere, we don't know where exactly, but here is your 50 GF. And we move the thread such that it gets balanced. I've taken this distance as X. A heavier weight has to come closer so that the movement becomes, the force is more, so we have to decrease the distance to balance the torque, But the exact distance we don't know, so we keep it as X. Now, this is a balance situation. So in equilibrium, anti-clockwise movement is equal to clockwise movement. So this side is anti-clockwise, this side is your clockwise movement. Let's see how much is our anti-clockwise movement. So it's force multiplied by the distance. And remember, there's only one movement on the anti-clockwise side. If there were two weights, accordingly, we do F into D1, then F2 into D2. So here there's only one weight. So 25 GF multiplied by 50 centimeters equals. Now we go to the other side. On the other side, the force is 50 GF and the distance from the axis of rotation is X. Now to find X is 25 GF into 50 centimeters divided by 50 GF. So this divides it twice and 2 divides it 25 times. So we are getting 25 centimeters. Now we need to express our answer properly. 25 centimeters is this distance. So one way of writing our answer is 25 centimeters from the fulcrum or from the support on the right hand side. From the support on the right hand side. Another way of writing the answer would have been at the 75 centimeter mark, since we have a drawing to support what we are saying. So here's 50, another 25 centimeters will make it the 75 centimeter mark. So this was a very simple sum. Please write in the comment section if you want me to discuss more sums, numericals like this. Thank you. See you again in the next video.